Okay, make a video. Okay, you guys. So the first thing we need to look at when we look at a problem is we need to find out, is there any talk of energy in the problem? If yes, is the energy coming in or going out of the system? Okay, so let's take a look and see if they're talking at all about energy. Okay, let's just see. They said when solid zinc is added to hydrochloric acid, the products are hydrogen and zinc chloride. You could feel the test tube get hotter, okay? All right, so when I see the test tube gets hotter, oh boy, that says to me we got energy in this experiment other than the ones that we have just in the thermal energy and the chemical energy. Okay, so the test tube is getting hotter. So when I write my equation, right, which is the next thing, is the energy going in or coming out? I think it's coming out because they said that test tube gets hotter. All right, so next thing we got to do is write the equation. When solid zinc, all right, when solid zinc was added to hydrochloric acid, let's see if this will work. Oh, zinc was added to hydrochloric acid. What happens? Well, all right. The products are hydrogen gas. Okie doke, we can write that. Hydrogen gas, hydrogen, and then we can put gas if you want. Okay, and a aqueous solution of zinc chloride. And aqueous, you guys, just means liquid. Okay, so again, you just put aqueous, that means liquid. All right, there is our our reaction. You guys are going to need to balance that. All right, you're going to need to balance it. But we also know that the test tube got hotter, so we have some energy. Okay, all right. So let's see if we can move that up just a little bit. There we go. Okay, that looks a little better. All right, you guys. So now we need to look at the equation. We need to look at the equation to see what's happening with the energy. We know that thermal energy is the energy of the movement of the particles, right? Thermal energy is the energy of the movement of the particles. Okay, thermal. How fast the particles are moving. Right? Okie doke. Okay. And we know that chemical energy has to do with the energy between the bonds of the atoms. The energy between the bonds of the atoms. Are not between, but held within the bonds of the molecules. Okay? All right. So now what we're trying to do, this is simply an accounting of the energy. All right. So we're going to start out, you guys, with thermal energy. All right. We're going to put some energy in for thermal because we are never seeing zero amounts of energy, right? We never see zero. We never see the particles totally stop moving. Oh, that would be absolute zero, and we don't have that. So we're going to say that in the reactants, which is what we're looking at, that they are moving. All right, and then we're now going to look also at the chemical energy. So we have some bonds going on here. So there is energy within the bonds, okay? So what has happened to our the energy between the bonds? Well, we probably have some here, so we are going to draw that as well. We're going to draw that chemical energy as well. Okay. All right. Okay. So now what we need to do is to think about what happens. Okay. When the particles are put together, they begin to run into one another. They begin to run into one another. And when they run into one another, what is going to happen to thermal energy? Ms. Ford, what's going to happen to thermal energy when the particles start to run into one another? Yep, it's going to heat up. The particles are going to move faster because they start hitting each other, right? Very good. So we're going to have to increase the amount of thermal energy because we know um, that it's heated up. And the reason why it's heated up is because they're running into one another, and that's going to increase the speed. All right. But where did that energy come from? That's what we have to figure out. Where did the energy come from? In the discussion of the reaction, there is no talk about having put energy into the system. We know something about energy going out, but we know of nothing about energy coming in. So, where do you think that energy came from? Let's see here. Julissa, we just had an increase in thermal energy. Where do you think that energy came from? Correct. Absolutely right. It's the only place it could come from, right? Is the chemical energy. So we're going to have to reduce the amount of chemical energy because it is now gone out of the chemicals and into the thermal energy. All right. Okie dokie. So the final thing is what happens. Ellie Ryan, are you there? Do we lose Ellie? Oh, good. I'm glad you are, Ellie. Ellie, now I forgot my question. Yeah, Habibi. Um, all right. I don't know if I mentioned this before, but when after a reaction, the thermal energy, the speed of the particles is going to go right back to what it was at the beginning. And the best way to remember that is to think about, remember in middle school when everybody made a volcano, you guys took some baking soda and you put it in a cup and then you poured some vinegar in it, right? And it reacted and you got lots of gases and bubbles and but eventually it stopped reacting. So the thing that we got to remember is that the thermal energy will go back to the same energy it was at the beginning of the reaction. It will eventually go right back to the same amount of thermal energy, okay, that it had at the beginning. And the chemical, you guys, energy, once you have one reaction, there's not going to be a change. There's not going to be another change in the amount of energy that exists. We had this arrangement of the atoms, and then it broke up into this arrangement of the atoms. Okay, so we're not going to change the amount of chemical energy. All right. So now what we need to do is to just take a look at this. Let's see here. Kaylee Osborne, you there? Hey, Kaylee, how many bars of energy do we have at the beginning of our reaction? Yep, we have 4. All right, and how many do we have at the end of our reaction? All right, so we've lost some energy here, huh? We lost some. So where did it go, do you think? Into the air, absolutely. Into the surroundings. Absolutely right. So we lost it into the surroundings. So we got to show one bar leaving. Leaving the system. Okay? And that's how you draw it. And you just make your little lines, right? You make your little arrows showing it leaving the system. I can't do it for whatever reason. Yeah. One there. How come it won't work? Anyway, you guys see an arrow here, please, because I can't do it for whatever reason. There it is. Or not. Okay, that's it. You guys know how to do it. Just put it over here. Whoa. Boy, I don't know how you guys have the patience for this. I'm glad you do. I'm getting old. I don't have the patience for this anymore. All right, so you have to show it leaving the system. All right, I think, let's see here. We're almost out of time, right? We have 45. No, we got lots of time. Okie doke. So this will be your answer, you guys. This is your answer for what happened to the energy. We can account for it now because we started out with 4 bars and we're ending with 4 bars, right? All right. Okie doke. Let's go on. Oh, you guys don't have to do the last one. So you don't have to do, this is the last one you'll do. This is the one you don't have to balance. Okay, no need to balance this one. So you might want to write that in there. Okay. All right, you guys, I am going to have this due on Friday for you guys. Okay, so I will put up a video on, I'm making a video, never mind. So I will be putting up the video that I'm making for problem number, the one we just did, so you can reference it. These are, you're just going to notice a little bit of a difference in that as a result of this reaction, the pack feels cold. So you got to think about that a little bit on your injured ankle. So you got to think about where you're going to have to think about the energy. Did energy, well, you'll do it. You'll do it. So your homework, you guys, is to do 3 and 4. You may have some questions. I'm going to let you work on it right now. And then you can ask me questions. We're here for another few minutes. And then again, if you don't understand it later, just email me and I will write you back. Okay? All right.